Hello everyone, I am Dr. M. Manikam, Assistant Professor, Department of Physics, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. So in this video, we are going to see about the assembly language programs. Continuously, we are talking assembly language program in this lecture series. Today, we are going to discuss about assembly language program on ascending order in Microprocessor 8086. So in this video, we are going to see about continuously. First one, that is what is assembly language program, how we can write the codings or programs for the assembly language program on ascending order in Microprocessor 8086. Then how we can write the mnemonics codes and how we can draw the flow charts. So these are the things we are going to detailedly discussed in this video. So let's go into the video. Today in this video we will see about assembly language program for sorting an array in ascending order. So this is the video we will discuss in detail. Let's go to the video. So this is the source program for sorting an array in ascending order. So first step, that is starting point, that is move si comma 1100, which means set the SA register as pointer for the particular array, which array we are getting inputs. So next step, move CL comma SI. So which means the pointer SA register that will move to the CL register, which means set CL as count for n-1 repetitions. So this is the purpose we are, because we have many number of datas in an array, means we can do the details or fetching the inputs continuously up to the total number of the data in an array. So next step, decrement CL. So we have to one by one, for example, if it is count value is 7 means, so totally 7 values we will give as input. So we can count every one inputs, then we will move to the comparison part. So next step, move si comma 1100. So initial, which means initialize the pointer values. After the decrement of CL register, again we are repeating the same procedure up to getting all the inputs. So move CH comma SI. So next step, that is CH as this is a 8-bit register as count for n-1 comparisons. So first you have to fetch for the repetition purpose. Again we are getting the moving the SI register to or pointing address to CH register for comparison purpose. So it's next step, decrement CH. So likewise we have to repeat the things to get the all input data in an array. So next step, INC SI, we are incrementing the pointer value. Then repcom, which means this data will move to the another step. So our repetition purpose we are using repcom. Move AL comma SI, then INC SI. So now we have fetched the datas in AL register or some datas. So now an element of array in AL register. So next step, increment SI register, then compare AL comma SI. So we have 7 data, means first data we have take first data and we have to compare the first data with all other remaining data. So that's what we are using. That's why we are using a comparison instruction. So next one, JC. JC means jump on carry. So if you are comparing these two values, if you get the carry value, means it will jump to ahead points. So ahead points means that is decrement CH line, it will jump. So otherwise it will repeat the exchange AL comma SI, exchange AL comma SI minus 1. So these steps it will execute. So otherwise it will jump to decrement CH point. So next step, JNC repcom. So repcom means in previous slides we have discussed move AL comma SI. So that element array in AL register, this step will repeat after the step of decrement ch. Then after the j and z jump on non-zero, again it will goes to the decrement cl, then j and z jump on non-zero, repeat. So this process will repeat up to all the data is getting compared with each other datas. Then finally will end of the program, we will execute the end of the program, that is by using the instruction HLT. So HLT means halt the execution program. So this is the source program for the particular sorting and ascending order. So simply we can say it is the ascending order program is working in the microprocessor 8086 program. So first you take an array. So if in that array we have 7 data or 8 data means, so first we have to give the input, then we have to compare all the data. Suppose we are taking first data, take means we have to compare the first data with the second one, and third data, fourth data, up to seventh data. Then we have to take the second data and we have to compare all this data. So then only we can find out which one is smaller, which one is larger data. First we have to find, then based on the findings we have to arrange the numbers in ascending order. So this is the program for source program for sorting an array in ascending order. So next one, that is the algorithm for the particular program. First step, there are 15 steps is there. So first step, set SI register as pointer for array. So first we have to set the SI register for array. Then second step, CL register as count for n-1 repetitions. So this is for count purpose, we are using CL register and CH register also. So CH register is using for n-1 comparisons, CL register for counting purpose we are using. Then fifth step, increment the array pointer, then get an element of array in AL register. So first we are getting in array pointer in increment, then we will get the data in array AL register in an array. So continuously we are fetching the data, input data in AL register, then it will move to the increment the array pointer, then we have to compare with another data, then we have to check the carry flag, then exchange or increment purpose we will do, then check the 0 flag, then decrement, again check the 0 flag, then if it is not completed means it will repeat the same steps. So otherwise if it is completed means 0 flag is satisfied means it will stop the program, so the end of the program. So these are all the steps are involved to executing the program of sorting an array in ascending order. So this is the flow chart for the ascending order program. So there are 15 steps are involved. So one by one we'll discuss in flow chart. So first we have to start, then load the address of the array in SA register. Second one, second step continuously, that is load the count in CL register and decrement by 1. So then only we can find out the data, will fetch the data and compare with other data. Next step, load the address of array in SA register, and then load the count in CH register and decrement by 1, then increment the array pointer, then get an element of array in AL register, then increment the array pointer. So this is all the one by one step by step process. Many steps are involved in this particular program. So then finally we have to compare the next element array with the AL register. AL register has one data, so we have to compare with all other data in an array. So next step, carry flag. If it is S means it will move to the decrement CH count. Otherwise, if it is no means CF is not equal to 1 means it will move to the exchange AL register and memory pointer by SI register. Then exchange AL and memory pointer S minus 1 SI minus 1 pointer. So these are the steps are involved. Then again it will move to the decrement CH counter. Then again check the 0 flag. So if it is yes means decrement the CL count. So otherwise it will move to the get an element of an array in AL register step. So again it will repeat. So up to the zero flag condition is satisfied. Then if it is satisfied means it will move to the decrement CL count. Then again it will check the zero flag. So zero flag is 1 means if it is yes means it will stop the program or end up the program. If it is no means it will move to the step 3. So that is load the address of array in SA register. Again it will repeat all the steps. Then finally it will stop the program. So these are all the steps are involved. This is the flow chart for the ascending order. So this is the sample data for ascending order. So suppose input data we are taking 7 data means that is 07 we are taking as count in the memory address 1100. So all other remaining or data input data in an array, that is AA 77 FF 22 11 44 and BB. So these are the input data we are before execution we are giving. Then after the execution we will get the output as 11 22 44 77 AA BB and FF. So after the steps are all the steps are involved. After the execution, step by step execution, we will get the output data like this in ascending order, the smallest to largest number. So the applications for the particular ascending order where we are using in day-to-day life or some other electronic components where we are using means first one that is sensor data sorting. So it is a data sorting purpose we are using. So organize the layered real-time sensor readings, for example temperature, pressure, gauge. So these are all the things. The analysis purpose we are using this ascending order sorting program. The next one task scheduling. Short tasks by priority or execution time in real-time systems we are using task scheduling purpose we are using this ascending order program. Then digital signal processing, database management, memory allocation, inventory system, educational labs purpose we are using. So in education lab purpose it demonstrate sorting, logic, loop control and memory access. In microprocessor courses we are using this kind of ascending order details. So ascending order means data different value datas are shuffled and we have to arrange properly. So this kind of automated system, in automated system we are using this kind of ascending order programs we are using. Wherever the data processing or signal processing is needed, so we are using this kind of programs to solve the particular problems. So thank you for watching this video. Thank you.